thing for us to think about, the last thing as far as Cauchy-Euler equations for us to think about are, what if you wanted to solve the differential equation x squared y double prime minus xy prime equals e to the x? Well, this is a non-homogeneous Cauchy-Euler equation. It's a second-degree non-homogeneous Cauchy-Euler equation. And what you would do is you'd have to find the complementary solution first, and then find a particular solution. And once you had those, then your general solution would be the sum of those. So to find the complementary solution, you just basically do what we were doing before. So to find the complementary solution, you let y equals x to the m, right? So y is x to the m, and then y prime is m x to the m minus 1. Y double prime is m times m minus 1 x to the m minus 2. And then you could put everything together and you end up getting m times, so your equation becomes m times m minus 1 minus m equals 0. So you end up with m squared minus 2m equals 0. So m is 0 and 2. And so your complementary solution is going to end up being c1x to the 0 plus c2x squared, and that's fine. Okay, so that part's no big deal. To find the particular, so you can think of 1 and x squared as your two linearly independent solutions. You have a 1 and an x squared. To find the particular solution, what you would do is variation of parameters. So to find the particular solution, you would use the variation of parameters. That's where if you have a second degree, if you have a second order equation, you have two linearly independent solutions, which we just said 1 and x squared are the linearly independent solutions. Then you can find the particular solution that way. If you do that, that will let you find the particular solution, and then once you have that, then your general solution will be the sum of the complementary and the particular solution. Okay, I'm not even going to go through finding the particular solution using the variation of parameters. You can go through that. It's a decent exercise. I haven't gone through it, so I don't know that it works out nicely, just as a forewarning there, but that's how you would do that. So you'd use the variation of parameters, then you would already have the complementary solution, add them together, that'll give you your general solution, and then you go take a nap. Okay, it's a lot of work for just solving that kind of innocent looking equation. Okay, but that's really all I wanted to say about these Cauchy-Euler equations.